Okay, students, so now you should be on the second part of your notes. You should have already watched the video and done the notes for area of a triangle, and now we're moving on to area of a trapezoid. And remember, you should have also already watched the other videos in Canvas on area of a trapezoid and triangle. So first, let's look at these three trapezoids at the top of the page. And I want you to draw lines to make these trapezoids into other shapes or decompose them. Try to draw as few lines as possible, and I want you to split them into squares or rectangles and triangles when you're drawing your lines. So go ahead and pause this video and draw your lines now. Okay, this is how I drew my lines, trying to add as few lines as possible to split them into rectangles and triangles. And as you should have seen in the Anywhere Math video, they did a lot of animations and cool things to show you how the area of a trapezoid is very similar to the area of a rectangle. And so please watch that. If you haven't, it will show you a lot more than what I can show you on just this Word document. So now that we know that a trapezoid is basically rectangles and triangles put together, sometimes two triangles, sometimes just one, depending on how the trapezoid looks, let's talk more about the formula for finding the area of the trapezoid. So filling in on your notes, a trapezoid is one or two triangles, just like what we saw here, and a rectangle combined. The most important thing that makes a trapezoid is the fact that it only has two parallel sides or one set of parallel sides. A rectangle has two sets of parallel sides. So we can see on this rectangle I made here, this and this would be parallel to each other as well as this and this. But because the trapezoids have the triangles added in, this top and bottom part would be parallel. But if we were to extend the lines on these other sides, they would intersect eventually. So it's only one set of parallel lines. And as you saw on the other video, we used that symbol to show parallel lines. So just a quick note on that. Okay, so when we are finding the area of a trapezoid, the formula that we use is kind of long. It is 1/2 base 1 plus base 2 times the height. Now again, we should know that the order we multiply really doesn't matter. However, there is addition in this formula. The parentheses are there for a reason. We have to follow order of operations, and we have to add the two bases before we do any of the multiplying. So just make sure you're paying attention to those parentheses when you're doing this work and that you're adding the bases first. And when it's talking about the bases, B1 is the length of the first base, B2 is the length of the second base. Honestly, it doesn't matter which one you say is the first or the second. The bases come from the parallel sides. So this would be a base, this would be the other one. Here's one of the bases, here's the other one, and the same on this one. The slanted sides are never the bases. So the base, B1 and B2, it has to be the two parallel lines. So if we were to turn this trapezoid on its side, okay, there's my horrible drawing. It's hard to draw with a mouse, but if I flip this trapezoid on its side, it might be confusing to some. You might want to think of this as the base, and this is the other base, but it can't be. The bases have to be the sides that are parallel to each other. So even if you see a trapezoid that's turned, it's always those parallel sides. So just be careful for that. And then the height is the height of the trapezoid. From top to bottom, should make a perpendicular line with the base. So this would be the height. These lines would both represent height, and my lines are kind of crooked, but let's pretend they're straight. Those would represent height as well. And if we have a turned trapezoid, the height would go from one parallel side to another, making a 90-degree angle with those sides, or being perpendicular to those sides. So one thing with geometry, if you're a visual learner, which we all have our different learning styles, visual learners do great with geometry. They can turn these shapes in their heads, look at them all different ways. But if you're not a visual learner, that's okay. It's just going to be a little bit harder for you. Sometimes you might need to sketch the shape and turn it. And like I told you in the last lesson about rectangles, if I had you in class, we could use tracing paper to do that so you could get it down. Unfortunately, I don't get to see you again this year, so we're going to have to do the best we can, but just know that you can sketch the shape, you can draw it, and make it look in a way that's better for you to help you understand. Okay, let's try some practice problems. And actually, before I do that, I just want to make you aware that this formula is on the star chart, and the triangle one that we saw in the last video is on there as well, and you should have this. I know there was going to be a geometry star in high school several years ago, and I know this formula was on there too. So it's not one that you should have to memorize, the one for a trapezoid. But you'll do it so much you probably will end up memorizing it. So let's look at these two problems. Now the instructions say we're going to break them down into parts. We're going to try one of the problems that way, and then we'll do the other problem the way we do with the formula. So if we look at this first trapezoid, trapezoid number 1, if I were to break it into parts, I can make a rectangle and 2 triangles. Now, we have the height of the rectangle, if we're just looking at that piece. We have 16 down here, but that 16 is referring to this whole base, the whole length of the shape. If we're just looking at the rectangle, we wouldn't want to use that 16. So most of you are probably saying, well, it would be 8, and you are correct. This piece up here is 8 centimeters. That means just this section that we care about for the rectangle, that would be 8 as well. So if we're looking at area of the highlighted part, the rectangle, base times height would be 8 times 6. So this has an area of 48 square centimeters. Then we have 2 triangles. Well, we can see the height of this triangle is 6. Since we have a rectangle here in the middle, the height of this triangle would be 6 as well. Now, there's not all the markings on here that there should be if we were actually in the geometry class in high school, but we're going to assume that the bases of each triangle, that they're congruent. So, if this section that we just used for our rectangle is 8 and the whole length is 16, we've got to figure out what the bases would be on our 2 triangles. And let me highlight those in a different color. So we have triangle here and a triangle here. We know the height on each triangle is 6, but we don't know the base. So, thinking about that, this whole thing is 16. The chunk in the middle with the rectangle is 8. So if we subtract 16 minus 8, we get 8. 8 is what's left over, but we have 2 triangles here. So each triangle would have a base of 4. And again, we have a formula for this. This is actually harder than what it needs to be, but I just want to introduce you for it because as you get older in geometry, you will be missing pieces and you might have to deconstruct like what we're doing here. So if this is totally confusing you, put it out of your mind after this for a couple of years. But anyway, we figured out the area of the rectangle in the middle. Now we're looking for the area of the triangles. If they each have the same base and the same height, they're going to be congruent because they're also right triangles. So if we find the area of one triangle, we would know the area of both. Some of you might also thinking, well, wouldn't the 2 of them put together make a rectangle? And yes, they would. So we could look at this a couple of ways. We could do base times height times 1/2 and then multiply that by 2. Or we could just think of them as coming together to make one rectangle, and if the base is 4 and the height is 6, 4 times 6 is 24. So we have 48 and 24, putting that all together, we would have 72 square centimeters for the area of this entire trapezoid. So that is finding the area if you break it down into other pieces. Like I said, that's pretty tricky, and luckily we have this formula here and we don't have to do all of that right now in 6th grade. So let's use the formula for trapezoid 2. Our formula says 1/2 times base 1 plus base 2, that's in parentheses, so we're going to do that step first, times height. So let's go ahead and fill in that formula. Area equals 1/2. Base 1 and base 2 are in parentheses, and remember those are the two sides that would be parallel. Doesn't matter which one I put first. I can do 10 plus 13 or 13 plus 10 because we're adding. It would give me the same outcome. And then the height is 8 inches for this one. Since this is a rectangle here in the middle, this height that's marked would also be 8 inches. So now we have 1/2 times 10 plus 13 in parentheses times 8. We would do this step first. 10 plus 13 is 23. And then we're multiplying that by 1/2 and by 8. Now, just like I talked about on the other video, if you want to change up the order, since it's multiplication, you can. What is half of 8? Or 8 divided by 2. That's 4. So now I can do that step pretty easily and multiply 23 times 4 to get my final answer. 3 times 4 is 12, 4 times 2 is 8, plus 1 is 9. So we have 92 square inches, or 92 inches squared is the area for trapezoid 2. Okay, I want you to pause right here and see if you can figure out the area of this shape below. Okay, you should have set up your formula to look the same as mine. Our bases in this trapezoid are 12 and 7. Those are the sides that are parallel to each other, and then our height is 4. Now remember, if you set it up for this part in the middle and you put 12 plus 7, you are perfectly fine. You do not need to erase anything. Now we need to follow the order of operations and solve. So we're going to perform our addition in the middle first, and then the multiplication. So go ahead and try that and then check your answer. Okay, so step 1 would be 7 plus 12, which is 19. And then I just copied my formula again, so I have half times 19 times 4. When I multiply 19 times 1/2, I get 19 halves. That's an improper fraction. So then I had to divide 19 by 2, and I got 9.5. And now my last step would be to multiply 9.5 times 4. Okay, and I multiplied 9.5 times 4, and I got 38. Now remember, because there's a decimal point there, I have to put it in my answer. So it would be 38.0, which is the same as 38. And it would be 38 square inches, or I could put the little 2 for 38 inches squared. Now let's look at our last problem. Betsy has calculated the area of the figure below to be 52 square centimeters, or centimeters squared. Determine if she is correct or incorrect, and then explain. So I want you to pause the video, calculate the area of this trapezoid, and see if she is correct. Okay, so you should have set up your formula just like this one here. You could also do 8 plus 5 instead of 5 plus 8. Second step would be 1/2 times 13 times 4, because 5 plus 8 is 13. And then you're going to go through, you could either do 1/2 times 4 first and get 2, and 13 times 2 would be your last step, or 1/2 of 13 and then multiply by 4. Either way, your answer should be 26 centimeters squared. So Betsy is not correct. She got 52. And depending on how you go through your steps, the 52 comes from 13 times 4. So what she forgot is to multiply by 1/2. So if you got 26 and you figured out that she was wrong, you are correct. Great work, guys. Make sure you take your Canvas quiz for this week so you can get credit. Have a great day.